Hi everyone. Before I start, I would like to thank the organizers for putting together such a huge conference, and it's really smooth and enjoyable. It makes the future conferences not feel as fun other academic conferences. Thank you so much. Thank you. So I'm a philosopher of mathematics, a mathematician turned a philosopher. I hope that at some point I can encourage you, invite you to do some collaborations with philosophers. So my work is on the famous paper by Eugene Wigner, The Unreasonable Effectiveness of Mathematics in the Natural Sciences. I believe most of you have read the paper. Wigner won the Nobel Prize in 1963 for his contribution to the theory of atomic nucleus and elementary particles. We all know that, along with Hermann Weyl, he introduced group theory into physics. So what is the question of applicability of mathematics? It's the question of why is it that math is so applicable in natural sciences, especially in modern physics. Wigner calls that the empirical law of epistemology. As you know, some people have written papers saying that math is not that effective, and some people have written papers that have said it's not so unreasonable. So I wonder where you sit in relation to applicability problem. But why is there a problem? So to motivate it is that it seems that there are two distinct entities. One of them is mathematics, that Wigner defines as an artistic creation almost, that is made for its beauty and with internal standards to mathematics, like rigor, like elegance, and so on. So on one hand, we have mathematics. And on the other hand, we have physics, which is the physicist, unlike the mathematician, Wigner says, is interested in inanimate nature and in discovering regularities that exist among the natural phenomena. So on one hand, we have physical objects that seem to be causal and spatiotemporal, and mathematical objects that are outside of the flow of time and causality. So why is that they have such a relationship with each other? So ultimately, what is in the background of applicability problem is what we can call a distinctness thesis. Math and physics, they seem to be dealing with different objects, or maybe their methodology is different, or there are different kinds of knowledge that we have. So Wigner says, it sounds like we are so lucky. It's like a man that is provided with a bunch of keys. So imagine somebody has made these keys in an art exhibition, and they give it to you, and you go home, and you use the key, and you can open the door. It sounds like a miraculous situation that mathematical concepts that were made for their beauty end up playing the role that they do. I have a quote from Dirac and Hilbert that they both also talk about, is that this unity of thinking and being, is that not really strange that this is happening? Well, this is a formulation. It's an argument form that you might agree or disagree with certain parts. Mark Steiner formulates the problem this way. As I said, it's the idea seems to be mathematical concepts come from static impulse. It's unreasonable to think that they would play such an important role in physics, in the study of nature. Even though there is this distinctness, it seems a significant number of them are significantly effective in physics. So I wonder if you accept the argument as therefore mathematical concepts are unreasonably effective. Now, there are many reactions to this problem. You might say math is not so effective in other sciences anyhow. It's probably a small portion of our knowledge in modern physics. You might also say, well, in pre-modern physics, math didn't play that role. So basically, the idea is that don't get too excited. Really, we don't have that much of a relationship between math and our empirical sciences. You might also say majority of maybe pure math is not that useful, et cetera, et cetera. So these are reactions to the problem. So one thing is that probably some of you would disagree with Wigner saying that, look, I don't think this characterization of math as being something that has been made on the basis of our aesthetic impulse, maybe that's not quite accurate. So Wigner was a Hilbert School formalist, formalism being an account that a lot of people accepted in middle of 20th century. So you might say it's Wigner's philosophy of math that creates miracles out of the thin air. The thing is, once we start thinking more about it, it seems that other philosophies of mathematics don't do much better. So as most of you know, Martin Gardner was a realist about mathematics. So on one hand, you have Wigner, that is a formalist, and then on the other hand, 180 degrees different, we have Martin Gardner, that is a realist. But also, if you ask a realist, how is it that we have this relationship between math and physics and math and nature, they don't have a better answer to give. All right, okay, so I'll wrap up. So my diagnosis of the situation is that we really don't have a good account of what mathematics is. Partially, people who respond to the applicability problem are people who have started with an account of math on one hand, an account of physics on the other, and then they want to talk about the relationship. I wanted to go on, but I don't have time. So my proposal to you is that we need close collaborations between mathematicians who know what math is and philosophers who can philosophize about things, so we can solve the problem of philosophy of mathematics. Thank you.